The second timer example is going to take a look at the way that the scans and the way a reset can affect the outcome of the ladder. So once again, I have a start button and a timer. This time I have a retentive timer, and I'm going to use the retentive instantaneous, or the EN bit, to hold itself in. Looks like when this gets done, it's going to break the rung. But remember, breaking this rung does not reset the timer. You actually need to have the done bit here activating the reset. So this is not going to reset it. All this is going to do is break the latch, or break the memory to the timer, so that when we reset it, it doesn't automatically start timing again. So here we go. I'm going to go ahead and hit the start button here, and you can see about 5 seconds later it's going to get done here briefly, just for one scan. Apparently this rung was true for a scan because it held itself and we have memory there. Okay, so just to show, the done here is executed, and it is applied to this rung as it scans, and it's applied to this rung as it scans, because it resets, and then it's applied to here, so it's breaking this rung. Okay, and then the way it did the inputs there, based on the output here, then the reset is applied to the timer and it goes back to 0. Okay, so what I'm going to do is I'm going to change this a little bit to make it pretty obvious of how it takes that rung and then takes the inputs and updates the outputs. So I'm going to go ahead, I'm going to move this reset up to here. Okay, now I went and did this offline because I wanted to show you something. So here, when I go to download, oh, it's going to let me download. It says there's a failed response. So if you get that, sometimes what it does is the communications are a little bit confused, especially if you're jumping between the DF1 and the UIC, so you can't download. So a little bit of a harder download is go to COM System Comms. You'll see the SLC 500 here, and if you populate it, you'll see it in this view here. And then if you click download, what it does is it tells you that you've switched your communication driver, which we have. You know, we've been jumping around a little bit, and so that's a little bit of a harder download, and that usually is effective to getting it download. And then if you're using the DF1, you might have to then go back to and auto configure on the DF1 so that Lynx sees it again. But those are having problems with downloads. Up here, this comms will help you. Okay, so this time what I've got going is I've moved the reset up to here. Okay, so now what's going to happen, it's the same ladder program that we had before, except that the done bit and the reset was over here. So I'm going to come up and I'm going to hit the start button. I'm going to let go, and it's being held here, and so this is going to get 3, and it's done. But the light did not come on this time. Last time it did. And so what is happening? Well, this is getting done. Okay, so it's running its logic inputs here, causing the output, the timer, to run, and then the timer gets done, so it runs its inputs again. We've no longer made this. You know, we've got a holding circuit. This gets done and this gets done, and then what it does is it will go ahead and write the outputs. Well, when it writes this output for the reset, that this is then no longer done. So by moving the reset around in your program, you can get things to occur in different ways. A lot of times it might make sense just to put the reset at the bottom of the program, but sometimes you don't actually want that. You would want the reset to occur in the middle of the program so that you can continue on with your logic without the timer, the counter, affecting the logic from down under. And so that incorporates some things related to state manager. Okay, and that's what you'll talk about in the lab.